Okay, welcome to our second day of notes in Chapter 1. This is Chapter 1.2, Translating Verbal Expressions. Now, if you happen to be following along in one of our normal textbooks, you will notice that this section is not actually Chapter 1.2 in the book. What I have done is taken some sections from Chapter 0 and Chapter 1 and kind of created my own version of Chapter 1 because there are certain concepts in Chapter 0 that we don't really need to get to and certain concepts in Chapter 1 that we really don't need to get to. So I've kind of taken the things that are important and made my own Chapter 1. So let's get started. Translating verbal expressions. What does this mean? Well, first let's talk about what an algebraic expression is. An algebraic expression can contain numbers, variables, and operations. We already know what operations are from the notes we did the previous day. Adding, subtracting, multiplying, dividing. And you can remember that because most of us know the phrase order of operations, and that includes addition, subtraction, multiplication, division. So obviously those are your operations, okay? Now, this is just fancy wording for what an algebraic expression is. Numbers, variables, operations. So a number such as 2 plus x. This would be considered an algebraic expression. Here's a number. Here's a variable, x. Remember, a variable is just a letter that holds the place value for an unknown number. And an operation, addition. Okay, so this could be an example of an expression. Now, the difference between an expression and an equation is that an expression does not have an equal sign. An equation does, hence the word equal in the word equation. Okay, so let's get started. What we're going to be doing is taking expressions like this that are written verbally, meaning in words, and turning them into math problems like this, or translating them rather into math terms, and then taking these math expressions and translating them back into words. So we're going to be going back and forth. It's very important to know how to do both. So first we have a word bank here. Just looking over some of these words, quotient of, multiplied by, product of. What I want to do is place the phrases from this word bank in the correct column below. So does the word mean addition, subtraction, multiplication, division? Well, we need to figure that out. I'll do the first couple with you, and then I'm going to pause the video and have you finish our little table, and then when you resume the video, you can check to see how you did. So let's start here with the first one, quotient of. Well, quotient goes with division. Quotient of. Okay, and me, normally as I go through a list, I cross things off. Times, well, 8 times 5. You heard this before in everyday math classes. So times normally goes, not normally, always goes with multiplication, times. Okay? Squared. Now squared is different. I'm going to skip this one and come back to it. Subtracted from. Well, the word is right there in the phrase, subtraction. So subtracted from. Okay. Less than, well, 8 less than 10. That would also be subtraction. But when you have the word than, you really need to be paying attention to the phrases that contain the word than, like less than, and I think I had another one over here, more than, okay? And we'll talk about what those mean in a minute. But right now what I want you to do is pause the video and continue filling out this table. When you are done, resume the video and see how you did. Okay, check how you did. Make sure you put them all in the correct place. If you made any mistakes, be sure to go back and fix them. Now, you'll notice that I kind of skipped two. I skipped squared and cubed. Neither those two don't fit in any one of these categories. So I'm going to make our own category off to the side here, and I'm going to call it exponents. Okay, think about your order of operations, your PEMDAS. The E in PEMDAS stands for exponents. So exponents is one of our operations. Now that's going to go with squared and cubed. Okay. We're ready to begin our examples. Write each as an algebraic expression. Okay, so here we have number 51, 21 decreased by 7. So what this means is you're going to go back up to the top of your page and find decreased by, if you don't already know, and it is part of subtraction. So this is going to be written 21 minus 7, which is 14. Okay, the sum of 6 and 9, well, sum goes with addition, so 6 plus 9 is 15. 25 decreased by 6, so 25 decreased by 6 is 19. Okay, the difference of R and 5. Now, the nice thing about difference of is that you can really put them in whichever order. I would just go in the order that it's read. So the difference of R and 5. 7 more than 8. So here's that word than that I had you highlight up here at the top. If you didn't, that's fine, at least underline. So more than. Now, your initial instinct is probably going to be 7 plus 8. Well, in this case, more than means that the second number comes first. 7 more than 8. So 8 plus 7. Okay. Now, you're noticing by now, hopefully, that I am actually solving these with an equal sign. And to be honest, I probably shouldn't be doing that because we are talking about expressions and not equations. But it's no big deal. If you're solving these, just extra practice. But do realize that the expression is just the part before the equal sign. Okay? 3 cubed. Well, that's going to go with our exponents. And by now, we know that cubed is going to go with the exponent of 3. Okay. So here over on this other side of the paper, the evens, I'm going to have you try on your own. Let's flip over to the back side and practice going from algebraic expressions to verbal ones. Okay. Now you're going to be able to use whichever terms that you want from our table. So if you'll notice down here, we had a lot of decreased by, we had that twice, the difference, more than. Get a little creative. Use some ones that maybe you're not used to so that you can start getting used to them. So 27 minus 20. Well, I'm going to flip over and say, I don't think I used minus yet. So I'm going to say 27 minus, minus 20. Okay. B minus 3. 3 less than, there's that less than again, B. Now notice how I put the 3 first because it's 3 less than B. Okay, be careful with the thans. 2 plus M, the sum of 2 and M. Okay, now yours don't have to be exactly what mine are. 8 squared. 71, just off the top of my head, the difference of 13 and A. And 2 times T, the product of 2 and t. Okay? So once again, I'm going to have you do the evens on the right side on your own. When you're done, make sure you remember to answer the questions posted on Schoology that go with this topic. It'll be titled the same way as your notes are. And come tomorrow prepared and have this filled out and ready to do our class activity. Thank you.